Okay guys, now that we know how to properly row reduce a matrix, we spoke about this a little bit earlier. There's at least 4 different types of matrix problems that we need to learn how to solve. We need to know how to solve a system of equations. We need to know how to find the inverse of a matrix. There's also word problems that involve more variables and solutions. But the one problem that you can expect to show up on your test as problem number 7 is a Leontief input-output problem. And we'll take a look at a couple of ways of solving this problem. Of course, we'll start by seeing how the book does it and some of your teachers show you how to solve the problem. And then we'll take a look at how we can solve it in a much more efficient fashion, showing you a fairly big trick to solve the problem. Let's see what we have. So the problem essentially is asked similarly all the time. Here it says that an economy is based on 3 sectors: agriculture, energy, and tourism. Production of $1 worth of agriculture requires inputs of 20 cents from the agriculture sector and 40 from the energy sector. Production of $1 worth of energy requires inputs of 20 from energy, 40 from tourism. And lastly, production of $1 worth of tourism requires inputs of 10, 10, and 30 from agriculture, energy, and tourism respectively. Now, if a final demand of 20 million for agriculture, 30 million for energy, and 10 million for tourism is to be met, then solve the respective inputs satisfying these demands. Now, sometimes on an exam style setting, they will break this problem up into 3 parts, A, B, and C. Really here, we're only asking for the last part to find the inputs. And in order to solve the last part, we got to do parts A and B regardless. So the first thing we're going to do over here, the whole point of what they're giving us over here is to set up a matrix. Now, what you have to remember in this solution that there's a formula that we're going to have to apply in order to get to the answer. And that formula is this one: x equals I minus m inverse times d. So this is how we can solve for x. We have to apply this formula. Let's take a look at how to do that step by step. The very first thing we're going to do is we're going to read this problem and, as many times as necessary in order to find what we call our technology matrix, or M. There's only one place we can potentially screw this up, and that is to take the inputs that they're giving us and insert them into our matrix as rows. This is incorrect. We should insert them always as columns where we're speaking of inputs. So let's take a look at how we can set this up. Our technology matrix M is based on 3 sectors, and in our case, the sectors are agriculture, tourism, and energy, or agriculture, energy, and tourism rather. Energy and tourism. So the setup of the matrix is going to look something like this. And so we're going to read each sentence and insert our values, again, as columns and not as rows. So a production of $1 worth of agriculture requires 20 cents from agriculture. So agriculture and agriculture is 20 cents. And 40 cents from energy. So it's 40 cents from energy. Since they are not mentioning anything about tourism, we're going to put a 0 here. The next sentence says, production of $1 worth of energy requires an input of 20 from energy. So energy and energy is 20. And 40 cents from the tourism sector. Notice that agriculture was not mentioned and therefore 0 here. Similarly, it's 10 and 10 and 30. And so 10, 10, and 30. So this gets us started. We have now figured out what our technology matrix is. We now know what M is. And now the rest of the values become insignificant until we set this guy up. We're now in a position to actually set him up. Let's take a look at what that formula is going to end up giving us. So the next thing we're going to do is we're going to say, okay, if x is equal to I minus m inverse times d, let's insert. We have all of the ingredients we kind of need now to be able to set up this formula. So it turns out that I stands for the identity matrix, and it is always 1, 0, 0, 0, 1, 0, and 0, 0, 1. Minus M, M is our technology matrix, the one we just found over here. And so that is going to give us 0.2, 0.40, 0, 0.2, 0.4, and then finally 0.1, 0.1, and 0.3. We have to take the inverse of this matrix and of course multiply it by D. Now to get the demand, we go back to our question, and the demand is 20, 30, and 10. And so we're going to insert that here, 20, 30, and 10. We can ignore the fact that they're in millions. All that means is that our final answer will also be in millions. So we don't need to add 6 zeros to the 20. Now we're going to spend one step simplifying this, and in order to do that, it is intuitive. In order to subtract matrices, as long as their dimensions are equal, we can do this, and we just subtract corresponding entries. So 1 minus 0.2, 0 minus 0, 0 minus 0.1, and so on and so forth. If we do this, here's what we're going to end up with. So 1 minus 0.2 is 0.8, 0, negative 0.1, negative 0.4, 0.8, 0 minus 0.1 again is negative 0.1, 0, negative 0.4, and finally 0.7. So we have to take the inverse of this and then at the very end multiply it by our demand of 20, 30, and 10. All right, so that's what we're going to have to do. And this is, up until here, you know, the book's method and our method is essentially the same. It is as of this stage that our methods differ a little bit. So before I show you the big trick that I spoke about, let's take a look at how we would solve this using, you know, the book's method or the conventional method. We're going to do exactly what the formula is implying. We're going to first of all need to find the inverse of this matrix. Now this is a pretty lengthy process as we saw in our previous problems, but let's take a look at how to do that. So that is obviously one of the longer problems that you guys are going to see on your exam. You know, row reducing a matrix, especially finding the inverse of a matrix, is a fairly lengthy process. And it took us this much work to get the job done. Let's take a look at our new way of solving this problem, and hopefully you guys will agree that this is a lot more simpler. So here's what we're going to do. As I said earlier, the procedure up until here is the same. Okay, the procedure up until here is the same. It is once we get here that I'm going to share with you guys a little, or actually a very big trick. Here's what we're going to do. We are going to simply sandwich this guy into one matrix and reduce that matrix only. We're going to sandwich this guy into one matrix. We'll also multiply everything out by 10, and we're going to reduce that matrix. We're not going to find the inverse. We're not going to multiply by the demand. In fact, our answer is simply going to show up. Let's take a look at how we can do that. So let's grab this guy. And send this guy down here. Where do you go? A little bit lower. So he's all the way down here. So we're going to start working with him. So we're going to remember what I said. We are going to sandwich this guy into one matrix, and we're going to multiply everything out by 10. What I'm trying to say here is we are going to solve the following matrix. If I multiply everything out by 10, I'm going to get 8, 0, negative 1. I'm going to just merge the two. So over here, if I multiply this guy out by 10, it's 200. And if I continue this process, here is what I am left with. And instead of, again, finding the inverse, getting our answer, and multiplying by the demand, we're simply going to row reduce this matrix and get our answer. Take a look at how much quicker this is going to be. So let's start the row reduction process. It's going to be a very similar one. So let's go over it maybe a little bit quicker. So we want this guy to be a 1. So I'm going to take row 1 and I'm going to divide it by 8. Doing so gives us the following. So 1, 0, negative 1 over 8. 200 divided by 8 should be 50. By 50, I mean 25. Minus 4, 8, minus 1, 300, 0, negative 4, 7, and 100. This time around, we're going to make this guy into a 0. So 4 row 1 plus row 2 gives us 1, 0, 0, 0, negative 1 over 8, and 25. And also, the last row will not change. The middle row, however, will change. So 4 times this plus this is 8. This is going to be negative 3 over 2. 4 times 25 is 100, plus 300 is 400. Divide everything here by 8. Dividing that guy by 8. Gives us the 1 at the appropriate location. And once again, the first and third rows do not change. The row that does change is the middle one. So dividing this by 8 is going to give us negative 3 over 16. And dividing 400 by 8 is actually 50 this time. Continuing along, we are now going to convert this guy into a 0. So the opposite of the number multiplied by the row that contains the 1 plus the row you are in. So this is going to, for sure, give us 1, 0, 0, 0, 1, 0. And this time, the first 2 rows will remain intact. And it's only the last row this time that is going to change. So let's take a look at what we will get here. So 4 times this, so it's going to be, so it's going to give us 25 over 4, I believe. Let's stick with our color scheme here. And then 4 times 50 is 200 plus 100 gives us 300. And we're almost there. 2 more steps. We'll get the job done. This time, row 3 multiplied by 4 over 25. So 1, 0, 0, 0, 1, 0, negative 1/8, negative 3/16, This guy for sure will become a 1. 25, 50. And so we have this one calculation to make. 300 times 4 divided by 25. That gives us 48. Lastly, we're going to convert these guys into zeros. And so that's going to give us 1 over 8 row 3 plus row 1. And then again the opposite times the row that contains the 1 plus the row you are in. And this is going to give us our answer, guys, as you will see in 1 second. So let's work on these values. So 1/8 of 48. So 1 over 8 multiplied by 48 plus 25. So that gives us 31. 3 over 16 times 48 plus 50. And that gives us 59. Let's take a look at these answers compared to the ones we previously had. We got 31, 59, and 48. 31, 59, and 48. Method 1, the books method, takes all of that effort. Method 2, our method, is a hell of a lot quicker, as you guys can see. Once again, to complete the problem, make sure you write down that exact same sentence. Inputs of 31 million, 59 million, and 48 million are required from agriculture, energy, and tourism, respectively. Make sure you keep the order exactly the same as it was provided in the original question. They had said agriculture, energy, and tourism, and so you keep that same order. So hopefully this trick is going to help you save a whole bunch of time in solving this problem, which is going to show up probably 100%. Let's move on to our next problem.